This is chapter 4-1, Triangles and Angles, lesson part 3 lesson. Please copy your cuts. Alright, just to begin, we're going to start with the Triangle Sum Theorem. The Triangle Sum Theorem is Theorem 4.1, and it simply states that the sum, or adding up the measures of the interior angles of a triangle, must equal 180 degrees. So if this is my triangle ABC, the interior angles A, B, and C, all three of those must equal 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C must always equal 180 degrees. So if I'm given a triangle such that I have here, and let's say that this particular angle is 105 degrees here, this angle here is 45 degrees, we could find the missing angle if this is angle Z. We could find the missing angle Z because the two angles here, 105 degrees plus the 45 degrees plus the measure of angle Z. So the measure of angle Z plus 105 degrees plus 45 degrees, all three must total 180 degrees. Combining like terms, I have 150 degrees. The measure of angle Z plus 150 degrees must equal 180 degrees. Subtract 150 on both sides, and the measure of angle Z will come out to equal 30 degrees. So we could just go and plug this in. Now that we know that the measure of angle Z is 30 degrees. Again, doesn't matter the type of triangle, if it's scalene, right, obtuse, acute, the three interior angles must always equal together 180 degrees. Okay? Now, having stated that, the corollary, I love saying that, corollary to Triangle Sum Theorem is the acute angles of a right triangle are complementary. What do I mean? For example, let's say I have a right triangle, any right triangle. When I have a right triangle, that one angle, let's say in this particular case for triangle A, B, C, angle C is 90 degrees. Well, if this is 90 degrees, that means that the measure of angle A plus the measure of angle B must equal 90 degrees, because we know the interior must equal 180 degrees. 90 plus these two must still equal 180 degrees. Well, that also means I could write this as the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. But the corollary simply says, the corollary to this just simply says, because I know that the measure of angle C is 90 degrees, that just means that the measure of angle A plus the measure of angle B equals 90 degrees. These two together equal 90 degrees. Okay? That's only for a right triangle, and we know it's right because they either tell us with the symbol or they writtenly tell us. Moving further. Triangles are sometimes extended past their vertices in terms of lines that run past. So here we have line AC, line BC, and line AB. Whenever this is done, I see I have angles A, B, and C. And angles A, B, and C are all the interior angles. They're the inside angles. Remember, interior, inside. They're the interior angles. Okay? But if I have lines that extend past a triangle, that means I'm going to have exterior angles. Okay? Exterior angles. What does that look like? This here would be considered an exterior angle. This is an exterior angle. Okay? Those are all exterior or outside angles. Let's look at another example so that you can see it a little more clearly. Okay? In this next example, I have triangle ABC, and again, A, B, and C are interior angles. Well, I see on the outside, these are rays this time and not lines. And on this ray AC, I have an exterior angle, angle E. Angle E is on the outside of the triangle ABC. I also have another exterior angle from ray CB. This exterior angle will be angle G. And finally, I see an exterior angle F. So there are 4 exterior angles on this particular example. 3 interior angles and 3 exterior angles. The 3 interior angles or 3 inside angles are A, B, C. And the 3 exterior or outside, remember exit, outside are angles E, angles G, and angles F. Okay, so now we have interior and exterior angles. All right. Finally, we have theorem 4.2, exterior angles theorem. This simply says the measures of an angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. What does that mean? Here I have angle C. This is where it's important to make sure we begin naming angles with their 3 vertices. So I might say angle A, C, B, and this one doesn't have B, C, and if I name this over here, G, angle BCG, or in this particular case, angle 1 or angle BCG, whichever you want to call it, is the exterior angle. And the exterior angle theorem states that angle 1 or angle BCG, whichever you call it, angle 1 can be calculated by the 2 angles that it doesn't touch. The 2 angles it doesn't touch are angle B and angle A. It is never the angle that it's next to, the adjacent. Okay? So for example, if I'm trying to calculate angle 1, if I know the measure of angle A and the measure of angle B, I can find the measure of angle 1. So on this particular problem here, let's say I have a triangle such that I have like so, and I'll just redraw A, B, C, and I'll let this be angle 1 again, my exterior angle, and I know that this is 85 degrees, and this will be 25 degrees. Okay? I can find the measure of angle 1 here simply because of the exterior angle theorem. The measure of angle 1 is going to be equal to the measure of angle A plus the measure of angle B. I'm just substitute in. So the measure of angle 1 we don't know. The measure of angle B is equal to measure of angle A is 85 degrees plus 25 degrees. Okay? And when we combine that together, we should find that the measure of angle 1 is simply going to be equal to 110 degrees. Okay? So now I know the measure of this. And since I'm jumping ahead, I could also find the measure of angle BCA, this angle here. How do you know? Well, angle 1 and this angle BAC, these two form a linear pair. So if it's 110 out here, that means what's left is going to be 80 degrees. But that's another lesson in itself. All right, this concludes chapter 4-1.